and Venn diagrams. If set U equals all positive integers and set A equals x's such that x is an element of U and x is an odd positive integer, which describes a complement. So first of all, here's a Venn diagram of what they're describing. Set U, and here it seems like they're using U to represent the universal set. So for this problem, the universal set is all positive integers. And then we have the set A, where A includes values that are obviously in the universal set of positive integers. But in addition to that, they are odd. So this is really the key piece of information about A, is that they're positive integers. Everything in the universal set is positive, but set A is the odd ones. Okay, so that means set A is a subset of the universal set. Now this A with a little c on it, this is called a complement. Which sounds funny when I say it like that, like a compliment. A complement. That means everything in the universal set that is not in A. All right, everything except for A. That's what a complement means. All right, so basically a complement is whatever would be in this zone right in here. All right, so this would be a positive integer still, because we're still talking about the universal set. But if it's not odd, then it must be even. So a complement should be positive integers that are also even. This is what we're looking for. Okay, let's see. So a complement, values that are in set U. Okay, I mean that's a universal set. Notice that they all have that, so we can pretty much ignore that. Okay, that's the positive integer part. So we're just focusing on we're looking for the one that says and even. And negative integer, nope. And is 0, nope. And is not an integer, nope. And is an even, ding 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 ding, positive integer. So that's the one. All right, the universal set is the set of rational numbers. Okay, so here's the universal set. And these are rational numbers. Okay, S is the set of integers. Okay, so integers are a subset of rational numbers, so I'm going to put that on the inside, integers. Okay, and this is the set S. Okay, which represents S complement. So again, S complement is everything that's in the universal set that's not in S. S complement means everything except for S. So S complement is everything that would be in this zone. All right, a rational number but not an integer. Okay, so we're looking for something that is a rational number and not an integer. Okay, let's see, is real, is rational, positive number, is rational non-integer. So rational not an integer. That's what we're looking for. And there you go. Alright, consider set U, which is the set of all x values where x is a real number. Okay, so that's a universal set if I ever heard one. Okay, so this is set U. Alright, definitely the universal set. And these are the real numbers. Okay, let's see. Now we have sets A and B. A is the set of values that are in set U, of course, because that's going to be the universal set, and they satisfy this equation. X plus 2 is greater than 10. Set B is a set of values that fit the inequality 2x is greater than 10. So which statements are true? Well, this is going to take a little bit more explanation for me. So let's look at set A for a second. Everything I do for set A, I will do in pink. So here's set A is given by this inequality. Okay. Now, for set A, we know that x plus 2 is greater than 10. But if I subtract 2 from both sides, that tells me that we're talking about x values that are greater than 8. Okay, so that's set A is x values that are greater than 8. So let me try to get this Venn diagram going here. So this is set A, and these are x values that are greater than 8. Now, switching over to green for set B. Alright, so here comes set B coming at you. 2x is greater than 10. So dividing both sides by 2, that means x is greater than 5. Okay. So in my mind, I'm asking myself, is there any overlap between these two? Are there numbers that are greater than 5 and greater than 8? Yes. However, let us be careful, because if you stop and think about it, any number that's greater than 8 is automatically going to be greater than 5. So everything in set A is going to be greater than 5. That means the entire set A should be inside of set B. Okay, so in other words, set A is a subset of set B. So because these are numbers that are greater than 5, and these are numbers that are greater than 8, but all of those numbers are greater than 5. Anyway, I'm not sure we really had to make such a great diagram to answer these questions, but let's see, which statements are true? The number 5 is an element of A. No, sorry, I said there's a little line there. Alright, the number 5 is not an element of A. Let's see, the number 5 is not an element of A because 5 is not greater than 8. The number 5 is an element of B. Nope. The number 5 is not an element of B because B has to be numbers that are greater than 5, not equal to 5. So that's a no. Alright, what about the next one? 6 is an element of A. Nope, 6 is not greater than 8. So that's no right there because of that. So this was 6 is not an element of B. Okay, that's also false. 6 is an element of B because 6 is greater than 5. So that's a no. That's a double no. 8 is not, and there's a line on this one, 8 is not an element of A. Okay, that's true. Set A represents things that are greater than 8, not things that are equal to 8. So 8 8 is not an element of A. That's true. 8 is an element of B. That is also true, because 8 is greater than 5. So we finally found one. That's both of those statements are true. So that's a true statement. Let's see. What about the last one? 9 is an element of A. Yep, 9 is greater than 8. 9 is not an element of B. That is false, because 9 is an element of B. 9 is greater than 5, so 9 is an element of B. So that's a fail right there. So this is the only answer. Okay, on this Venn diagram, which region or regions represent the union of set A and set B? A union B. Well, the union of two sets represents everything that is in either set A or set B, or in the overlapping part. So if I were to trace it for you, the union would be everything that would be contained inside of this pink border that I'm doing. Okay, everything in that shape, everything I just outlined would be in the union. Everything that's in set A, set B, or in the overlapping part. So zone 1, 2, and 3, all 3 zones. So let's see what we got. Yep, zone 1, 2, and 3. Boom. Okay, for this problem, we've got a Venn diagram. We're supposed to find which statements are true about X. Could be more than one. So before I start looking at these, let's check it out. X is in the intersection between B and C. So notice that X is in set B and it's in set C. It's in both of those, but it's not in set A. Of course, it's in the universal set. So we're looking for statements that would go along with that. It's in set B, it's in set C, it's not in set A. Okay, so X is an element of B union C. Well, that's definitely true, all right, because B union C is this zone right here. All right, and X is definitely in B or C. Let's see, what about the next one? X is an element of the intersection of B and C. Well, this is the intersection between B and C. Okay, that's what this little upside down U means, intersection. So that's another true right there. Okay, X is an element of the union of A and C. Okay, now the union of A and C is everything in A or C. So again, union works like this. All right, I'm outlining A. I'm outlining both A and C. That's the union of set A and C. And yes, X is in there because it's in C. Okay, so that's another true. Alright, so far we have 3 trues in a row. Very suspicious. Let's see. X is in the intersection of A and C. Alright, again, that's the symbol for intersection. Alright, I think we finally have a false. Alright, because this is the intersection between A and C. Alright, right here. Here's where they overlap. And X is not part of that intersection because it's not in set A at all. Alright, so that's our first no. X is an element of A. Nope, it's the one thing that it's not in. So we're not going to check that one off. X is an element of B. Yeah, it's definitely in circle B right here, so that's true. X is an element of C. Yep, X is inside of circle C for sure. Okay, so these are the 5. Let's see how we did. Excellent. The Venn diagram shows the number of patients seen at a pediatrician's office in 1 week for colds, C, ear infections, E, and allergies, A. Okay, you see all this overlapping. So, for example, there were 3 kids who were seen for colds and allergies, for example. Okay, that's what's going on there. There were 4 kids that were seen for what is this? Ear infections and allergies, because that's overlapping. So that's what we're talking about. All right, and there are 5 kids that were seen for some other reason than one of these 3. Okay, now let's see what they're actually asking us for. How many patients total were seen for only a cold, only an ear infection, and only allergies? Okay, so they want a total. So only a cold. Okay, so that's 4 people that were seen for only a cold. All right, none of this overlapping stuff. Only an ear infection. Okay, it's 9 people, 9 kids who were seen for only an ear infection, none of this overlapping business. And only allergies. That's only allergies. That's 15 kids. All right, so that's 15 plus 13. Okay, so that's going to be 28 if you add all these up. Okay, boom. There you go. Alright, so in this Venn diagram, the universal set is the set of whole numbers between 1 and 100. Okay, alright, so numbers 1 to 100, whole numbers. Now, A is the set of numbers that are perfect squares. Alright, B represents numbers that are perfect cubes, and C represents numbers that are perfect fourths. Okay, let's get some lists going, my good people. Alright, perfect squares. Remember, we're dealing with numbers 1 to 100. So here are all the perfect squares between 1 and 100. Perfect squares are numbers like 1, 4, 9. Okay, where am I getting these from? Alright, 1 times 1, 2 times 2, 3 times 3, 4 times 4 is 16, 5 times 5, whoops, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Okay, so those are all the perfect squares between 1 and 100. Okay, so here are all the perfect squares from 1 to 100. Now, set B is perfect cubes. So we're talking about 1 to the 3rd power, 2 to the 3rd power, 3 to the 3rd power, 4 to the 3rd power, 5 to the 3rd power. Let's see if we have to go that far. To help us out, let us use a calculator. So if I want to do a list of perfect cubes, I can hit this table button, and I can type in x to the 3rd power. And then I can go look at my list. Just hit enter a few times. Okay, so the first 3 perfect cubes, hold on, I want to be consistent and use blue. So 1 to the third power is 1, and then I have 8 and 27. So 1, 8, and 27. Okay, 4 to the third power is 64. Okay, I can keep using my calculator. But 5 to the third power is 125. Now, can you tell me why I'm not going to write that down? Alright, why am I not writing that down? Because we're sticking with numbers between 1 and 100. Alright, 125, that's too big. Alright, so that's it. So as far as numbers between 1 and 100 that are perfect cubes, that's the entire list. Now let's talk about perfect fourth powers. Okay, perfect fourths. So I'm talking about 1 to the fourth power, 2 to the fourth power, 3 to the fourth power. Will I be talking about 4 to the fourth power? I wonder. Okay, now I happen to know all these in my head, but again, if you hit your table button and you do this, make this to the fourth power. Okay, so we can see what's happening here. Obviously 1 to the fourth power is 1, but then after that we have 16, 81, and 256. I wanted blue. Okay, 1 to the fourth power was 1, 2 to the fourth power was 16, 3 to the fourth power was 81. 4 to the fourth power was 256, but again, that's too big. We're only doing numbers from 1 to 100. So these are the only 3 numbers. Okay, now the question is, which numbers satisfy A intersection C? Okay, so that means which numbers are in A and C at the same time. Okay, let's see. 1 is in A and C. Let's see. All right, 16. 16 is in A and C. And 81. 81 is in A and C. All right, so all 3 numbers in C are also in A. Okay, so there you go, 1, 16, and 81. That should be the answer. Boom. Consider the following sets. U, the universal set. We're talking about all real number points on a number line. Okay, so we're picture a number line. All right, all real numbers. Now A is the solution to the inequality 3x plus 4 is greater than or equal to 13. Let's do A in pink. Come on. All right, so here we go. This is going to be A. So let's see. We have 3x plus 4 is greater than or equal to 13. If I subtract 4 from both sides, that means 3x is going to be greater than or equal to 9. If I divide both sides by 3, that means x is greater than or equal to 3. Okay. So, just keep that in the back of your mind. I'm going to put that on the diagram later, but I want to see what set B is so I know what numbers to put. Alright, so now we're going to do set B, solutions to this inequality. So here comes set B. Alright, so 1/2 x plus 3 is less than or equal to 4. If I subtract 3 from both sides, that gives me 1/2 x is less than or equal to 1. Alright, to get rid of this 1/2, I would multiply both sides by 2. That's going to give me, alright, because these will cancel out. So x is less than or equal to 2. Alright, so I've got these two numbers I need to deal with, 2 and 3. Okay, so here's 2, and here is 3. Alright, now set A, those are values that are greater than or equal to 3. So picture it this way, values that are equal to 3 or greater. Okay, now set B, these are values that are equal to 2 or less than or equal to 2. Okay. Okay, so this again, this is set B, and this is set A. Now let's answer some questions. For which values of x is A union B the empty set? Okay, another way of saying this is for which values of x is x not an element of A union B. Alright, now remember, A union B means A or B. Okay, all of it, A or B, green or pink. So they're asking us which values of x are not part of either set. And I think it's going to be this one right here. Alright, the only values that are not in A or B are these values right here. Okay, between 2 and 3. Even the number 2 is in set B. The number 3 is in set A. So we need just the numbers between 2 and 3, and we can't even include 2 and 3. And that's exactly what this says. Alright, 2 is less than x, which is less than 3. This is another way of saying between. Okay, this is another way of saying between 2 and 3. Okay, so I'm definitely liking that first one. Now, what's the difference between the first one and the second one? The second one has these little equal to signs. That means they're including 2 and they're including 3. Equal to 2 and equal to 3. Okay, well, like I said before, the number 2 is in set B. The number 3 is in set A. We only want the values that are not in either set. So this is no good because because it includes 2 and 3. So it's just the first one. Okay, obviously the rest of these are wrong for their different reasons. This includes 2, this includes 3, that's no good. X values less than 2, alright, that's set B. Alright, it has to be the first one. Alright, that's going to be it for this video. I hope that it was helpful. Good luck on your quiz.